Welcome everybody. Thanks for gathering around the telescope. This is the third article that I looked at this week for the Astro News update for January 29th, 2026 here at Eadsy Astronomy. This one comes, you can see the link to the article and the link to the press release. They're on the post at Eadsy Astronomy on Patreon. Open free, you can get there so you can see both of these if you want for yourself. But this is zeroing in on the monster in M87, Messier 87. Most of us will know about that Messier 87, or we can remember it is the massive elliptical galaxy in the constellation of Virgo. It's about 55 million light years away. It's home to the now famous supermassive black hole M87 star, the one the Event Horizon Telescope, EHT, imaged back in 2019, 7 years ago, with that glowing ring around a dark shadow. And you can see it here. Here is the Event Horizon Telescope's image with the dark shaded area in the middle. There's the black hole. This is the Primo telescope, its version of capturing the same type of image. But Messier 87, besides the supermassive black hole and being the first to get photographed, has something else that makes it legendary. There, as you can see, both in the original post and you can see in this image now here, there's a blazing jet of particles shooting out from the center of M87. We imagine that there's so much material falling into the massive black hole, it can't consume it all, so it's ejecting out what it can't consume back out into space, thus the jet. This blazing jet of particles that come from the center, it stretches thousands of light years into space. It's almost like a cosmic blowtorch, really. The big mystery has always been exactly where, right near the black hole, does the jet actually begin? Where does it originate from? We may finally be getting close to the answer here. The Event Horizon Telescope isn't just one telescope. It's a planet-sized network of radio observatories working together using a technique called the Very Long Baseline Interferometry, VLBI. Thus, by using different telescopes spaced around the globe at different frequencies, this lets astronomers see different size scales. Some of these size scales are as following. They can see a very long baseline, i.e. tiny structures near the black hole, like the bright ring we've seen before, which I just showed you previously. They can also view very short baselines, i.e. large structures like the extended jet far from the center, and they can also see intermediate baselines. The in-between region, the crucial link between the black hole and the jet, and it is that in-between region that is exactly why where this new study focused using the EHT observations from 2021. Here's where the detective work comes in. I told you this was going to be a series of detective stories tonight. The team compared how bright Messier 87, M87 looks on different spatial scales. What they found was a mismatch. The bright ring around the black hole doesn't account for all the radio emissions detected. Some of the missing radio light shows up only on the intermediate baselines. That tells us that there must be another compact source of emission close to the black hole, something we hadn't clearly identified before at this frequency of 230 gigahertz. The best explanation? It's the base of the jet itself. Through detailed modeling, the researchers identified a compact region of radio emission located about 0.09 light years from the black hole. Now that sounds far, but on a black hole scales, that's basically right next door to it. Even more exciting, this location lines up with part of the jet structure that had previously been seen at a different radio frequency, 86 gigahertz. So now we're seeing multiple pieces of the puzzle from different observations and frequencies that are beginning to match up. This is one of the first time astronomers have been able to connect the black hole's immediate surroundings to the jet launching region in such a direct way. That's what makes this exciting. You can see from the paper here, here's the detected region, there's where the black hole is, that's the base they think of the jet coming out. You can kind of see that up here. There's the jet coming out, that's the base of it. And anyway, so this is important to us because jets from supermassive black holes can influence entire galaxies. They heat gas, They regulate star formation, and they shape galactic evolution. But we still don't fully understand how they're launched. This study provides to us three key pieces of information. First, a likely location of the jet's base. Second, a clear connection between the black hole's shadow and the outflowing jet. Then third, observational evidence to test theories about how magnetic fields and spinning black holes power these enormous structures. We're basically moving from an artist's impression to measured structure. And in science, that is so critical because it's the actual evidence we need to be able to make determinations, to test hypotheses, and come to conclusions. Now, the researchers aren't done. Future EHT observations will include more telescopes, including the Large Millimeter Telescope in Mexico, which means sharper resolution, better coverage of these critical intermediate scales, and the possibility of not just inferring the jet base, but actually imaging it. Now, that would be exciting. The same telescope network that gave us the first image of a black hole is now helping us to answer the next big question. How does a black hole turn infalling matter into a galaxy-spanning jet? With each new observing run, we're peeling back another layer of mystery around Messier 87 star, the black hole. And for those of us watching from our backyards, it's amazing to think that while we're looking at a faint fuzzy galaxy in Virgo, whether it's in our backyard, whether it's visually, whether it's with imaging, whether we're at a dark site doing this, at its heart, a 6 billion solar mass black hole is firing a particle beam across intergalactic space, and we're finally starting to see where the trigger is pulled for that. That's what's exciting about this. So this spring, as you look at M87, think back to this article, think back to what scientists are learning. We're getting close to actually understanding why that massive black hole is sending a jet out of material that's infalling that it just can't consume. We'll catch you next time. I hope you have clear skies. I was out tonight. It's nice and clear here with the moon probably about 96%, 92% full, and a little too bright for me to look at even with the moon filter. Jupiter looked gorgeous tonight. Take the time just to go up and look up, even if you're not going to use binoculars, even if you're not going to use a telescope. It's a wonderful night out there. Have a great one. We'll catch you next time.